Welcome, focused learners. I am absolutely thrilled to have you here today. We are taking on a fantastically practical topic, creating this video explainer for Chapter 11 of your mathematics journey. We're going to completely demystify factors, multiples, and divisibility. My goal today isn't just to help you memorize a few abstract math rules. Instead, we're building a real-world toolkit for organizing numbers, quantities, and, ultimately, organizing elements of our daily lives. From splitting up a crowded classroom to calculating the cost of your groceries, this is the hidden machinery making it all work. Okay, let's dive into this by stepping entirely away from the whiteboard and into a bustling school hallway. Think about this. How can we separate 50 pupils into equal groups? Imagine you're a teacher. You've got 50 eager students staring back at you, and you need to divide them up perfectly for a team project so that literally no one is left out. This isn't just theoretical math, right? This is a physical classroom reality that requires an immediate logical solution. How do we figure out the exact numbers that will divide 50 perfectly? To get there, we have a clear, step-by-step roadmap for our explainer today. First, we'll ask, what are factors? Second, we'll cover finding factors with tables. Third, we'll use the division method. Fourth, or scaling up with multiples. And finally, we'll unlock divisibility, the math's shortcut. Let's start right at the foundation with Section 1. What are factors, the building blocks of numbers? To solve that problem of organizing our 50 pupils, we first need to know what numbers are actually made of. So the crucial point is understanding the formal definition. When a whole number is written as a product of two whole numbers, those two numbers are known as factors of the original number. Think of it kind of like taking a giant Lego structure and snapping it into two distinct pieces. If you've got 12 chairs in a classroom and you arrange them into 3 rows of 4 chairs, the numbers 3 and 4 are the literal factors that build the number 12. Let's ground this in another highly practical example. Imagine you have exactly 30 apples. How many different ways can you bag them up so that every single bag has the exact same number of apples? Well, it turns out there are exactly 8 ways to group 30 apples. You could do 30 bags with 1 apple each. You could do 15 bags with 2 apples, 10 bags with 3 apples, or 6 bags with 5 apples. And of course, you can reverse all of those. These pairings, 1 and 30, 2 and 15, 3 and 10, 5 and 6, are the factors of 30. Going through this proves just how comprehensive and useful these factor pairs actually are in the real world when you're organizing inventory or sharing resources. But how do we actually find them without mentally drawing bags of apples every single time? That brings us to Section 2, finding factors with tables, the visual hunt. We are going to be number detectives here. And this brilliantly illustrates our point, a standard 10 by 10 multiplication table. This isn't just for rote memorization, it is literally a treasure map for finding factors. Let's say you're hunting for the factors of 20. Scan the grid. Where do you see 20? Boom! You'll spot it where the 2 row intersects with the 10 column, telling us instantly that 2 and 10 are factors. You'll also see it where the 4 row meets the 5 column, meaning 4 and 5 are factors. Let's go a bit bigger. Look for 72. You'll find it right there where the 8 row meets the 9 column. This grid allows you to visually track down the composition of almost any number in seconds. Now, what if the number is way too big for our grid? That's Section 3, the division method, the logical check. This method relies on one unbreakable golden rule. A true factor must divide into a number perfectly, leaving absolutely 0 remainder. Let's test this out. Is 9 a factor of 12? Step 1, we divide 12 by 9. Step 2, we note that 9 goes into 12 exactly 1 time, but we're left with a remainder of 3. Step 3, because there is a remainder, we can logically conclude that 9 is simply not a factor of 12. If it were a true factor, it would slide in perfectly with a remainder of exactly 0. It's a completely foolproof check. Let's move on and see how this builds in Section 4, scaling up with multiples, building numbers. We've spent our time so far breaking numbers down into pieces. Now we're going to build them up. It's incredibly common to mix up factors and multiples, so let's contrast them clearly side by side. Factors act as dividing blocks. The factors of 6 are the numbers that can cleanly divide into it: 1, 2, 3, and 6. Multiples, on the other hand, act as scaling up. If you start with 6 and keep adding batches of 6, you get multiples: 6, 12, 18, 24, and so on into infinity. To put it simply, factors are the pieces inside the box. Multiples are what happens when you keep ordering more boxes. So why do we even care about multiples? Because they dictate purchasing in our daily lives. If a ballpoint pen costs 12 rupees, the prices for buying 2, 3, or 8 pens are all multiples of 12. Or imagine 5 children buying delicious rambutans at 6 rupees each. To figure out what 1, 2, or 5 children spent, you're simply scaling up by calculating multiples of 6. Every single time you buy multiples of an item at the store, you're running this exact math program in your head. And finally, we arrive at Section 5, Divisibility, the math shortcut, or the cheat code, if you will. Now, what's really interesting about this slide is how brilliantly simple these rules actually are. Divisibility shortcuts let us instantly know if a number can be perfectly divided by another without ever bothering with long division. Today, we're looking at the rule of 10. Think about the multiples of 10. 10, 20, 30, 40, 110, 120. Notice a pattern? The visual rule is incredibly straightforward. If the digit in the ones place is 0, then that number is wholly divisible by 10. That's the whole shebang, no dividing required. You literally just look at the very last digit. So let me leave you with a quick challenge straight from the source exercises. Look at this massive number, 3150. Based on the shortcut we just learned, is it instantly divisible by 10? Well, look at that ones place. It's a 0. So yes, absolutely, without doing a single second of long division, you know for sure that 3150 is perfectly divisible by 10. You're now fully equipped to break numbers down, scale them up, and find the math cheat codes hidden in plain sight. So what does this all mean for you? It means you have the power to organize the world around you. What other massive numbers can you instantly conquer with these new rules? Keep exploring, and I'll catch you in the next explainer.